I'm going to start over since I forgot to record. Chapter 1, Section 1, Evaluate Expression. Evaluate expressions. What is an expression? An algebraic. Well, first of all, what's a variable? Okay. A variable is a symbol that represents a number. Okay. A variable. In our case, a lot of times in algebra we use letters. Okay. We use X, Y, Z a lot. We use A, B, C. Okay. We use all kinds of variable, a symbol that represents a number, a letter that represents a number. You may not know the number, or you may, but it is a letter or a symbol that represents a number. A variable. An algebraic or a variable expression. Okay, a mathematical phrase with a variable in it. A mathematical phrase with a variable in it. Well, we know what a variable is. What's a mathematical phrase? Do you know what that is? Mathematical phrase? Yes. Can you give me an example of one?
Like A plus B.
A plus B. Right, that would be an algebraic or a variable expression because it has variables in it. A mathematical phrase could be something as easy as 1 plus 1. Right? Mathematical phrase. But when we put a variable in it, so like 1 plus A, that makes it an algebraic or a variable expression. This is just a mathematical expression or just an expression. This is a variable expression because there's a variable in it. There's a difference. Remember, the difference between an equation and an expression is expression does not have an equal sign. An equation does. Right now, we're not dealing with equations, just expressions. Okay? There is no equal sign in what we do for right now. Okay? So let's do some examples. Okay? For example, an expression A plus 4, and we're going to say A equals 9. Okay? Well, we know A represents a number. What number? In this case, 9. So we're going to take that 9, plug it in for the A. Boy, 9 and A look alike, don't they? 9 plus 4 gives me, oh, no equal sign, 13. Final answer. Taking the number, plugging it in for the variable, and then solving. That's what I call plug and chug. Okay, you plug in the number, and you chug out the expression. Plug and chug. You're going to hear that a lot. Okay, let's do another one. What about 36 over B? And we'll say B equals 12. Done? Thank you. So I take my 12 and I plug it in for B. So I have 36 divided by 12. And then I chug. What's 36 divided by 12? 3. 3. Final answer. Yes?
Whenever we do like a homework part, do we have to put 12 and the 36? You can see the 36 in the B.
I want you to plug it in and then solve. You do not, like, for instance, in your homework, it'll have it, like, in your homework, it'll say this. It'll be 4 minus x, and it'll say x equals 1. Here's what I want you to write, okay? I'll do a different color. I want you to put in 4 minus 1, which you put 3 in the box. Okay? That's what I want your homework to look like. Okay, any questions about expressions? Some of you may have seen these before. Some of you may have never seen these before. Okay? Now, they get a little bit difficult. Okay, they can get more difficult than just what we've been doing so far. I'll do a couple examples in your homework. One of them says 4 over 7. What does that little dot mean again? Times. Okay, and we're going to say t equals 7/8. So I'm going to plug first. I'm going to take my 7/8, plug it in for t, because I know t, that's what t equals. So I have 4 7s times 7/8. Does anybody remember how to multiply fractions? Try it. Not cross multiply, that's what 99% of students say. This is a hated operation, yes.
Find common denominator.
Not the common denominator, that's how it's subtracting. Try again.
4 times 7 is 7.
Yeah, you're going to multiply straight across the top, straight across the bottom. Okay, now, before you do that, there is a shortcut to help you. Before we multiply straight across, does anybody know a shortcut to make it a little easier? You probably know it, you just forget it. You probably see it. You remember the words when your teacher told you to cross reduce or cross simplify? Has any math teacher ever told you that before? I call it cross reduce. Okay? That means, can you simplify any of the, before we multiply, can you simplify 4 and 8? What are they both divisible by? 2, and they're also divisible by something higher. They're both divisible by 4. So let's reduce 4 and 8. Let's divide 4 by 4. What's 4 divided by 4? 8 divided by 4? 2. So I'm cross-reducing before I multiply straight across. I would recommend it because they get a little more difficult. Yes. Get used to it. You don't have to, but then you have to reduce at the end. Okay? If you cross-reduce before you multiply, then you don't have to reduce at the end. Now, 7 and 7. Not multiplying, I'm reducing. Can I divide both of those by something? Yeah. Or not 1, but I can divide them both by 7. And then they reduce to what? 7 divided by 7 is 1. 7 divided by 7 is 1. Now, I have to multiply straight across. So I'm left with 1 over 1 times 1 over 2. Isn't that much easier than 4 times 7 and 7 times 8? I'd say so. Okay? So let's go ahead and do that. I have 1 times 1 no equal sign yet. Okay, 1 times 1 is 1, and 1 times 2, 2. My answer, 1/2. Let's do another one that has fractions in it. Okay, multiplying fractions, cross-reduce. If I were you, I'd make this a side note or make a note to myself so I knew where to go every time I had to multiply fractions. When you multiply fractions, I'll write it down for you. Okay? Multiply fractions. Okay, step 1. Cross-reduce. Step 2. Multiply. Does anybody know what the top numbers are called? Numerators, and multiply the what? Mike, would you do me a favor? Would you move your seat right here? Thank you. Grab all your stuff. Multiply the numerators, and then multiply the denominators. I've seen students, and I have these if you want them, grab these note cards, okay, like just a 3x5 note card, and put all the things that they usually forget or things on a note card and use it as a bookmark in your Algebra 1 book. So for instance, I've seen a lot of people get these and put multiplying fractions, and they put those notes right there. That way, when they get to a fraction problem, oh my god, I forget how to do this fraction problem, they grab it, oh yeah, I gotta do these. Okay, because a lot of students forget how any rules with fractions. Period. Are you one of those? Or do you guys remember fractions? I don't know. Or are you just staring blankly?
Pretty much.
Pretty much, yes. Okay, if anybody wants one, you can grab one. Okay. There's no shame in that. Okay, now another example. Okay, one from your homework. This one's a little difficult as well. W plus 2/5, and we're going to say W equals 1/2. Okay, so now we're adding fractions. Now, how do I add fractions, and what do I do? What's that? Nope, that's multiplying. We'll go straight across. Now, adding, subtracting, you remember what you said? Denominator. Okay, so first I have to plug. Take that 1/2 and put it in for W. Common denominator, what in the world? I have to look at my denominators, 2 and 5. Okay, so what I would do on my note card that I got, I would say, okay, common denominator for adding or subtracting fractions. I'll say add and subtract so I can leave off the I and G. Fractions, first step, common denominator. How do you find a common denominator? If I have 2 and 5, does anybody remember? Remember the letters LCM? Least common multiple. Remember? Do you remember doing those in like junior high or maybe a little older last year? Okay. How do I find the LCM of 2 and 5?
Go to like 1 and then 2.
You multiply them by 1, multiply by 2, multiply by 3. So I have 2. I'm going to write all the multiples out of 2. Okay, so it's 2, 4, 6, 8, 10, 12, and I can keep going, right? So I'm going to stop there for now. Okay, then I'm going to go to 5. I'm going to write 5, 10, 15, 20, 25, and I can keep going. Okay, I'm going to stop there for now. Now I need to find the one that's smallest that's common in the top and the bottom. So which one is that? 10. So that's my least common denominator, least common multiple. Is my 10. So I have to take that green box and I have to make those 10s. Once you find a common denominator, step 2, okay, is change the fraction. Change the fraction. So what do I mean by that? Well, how do I get, I always drew an arrow and said, okay, how do I get from 5 to 10? What did you do? What did you multiply by?
2.
Multiply by 2. And I put a little times 2 and I circle it. I'm like, so I remember, okay, to get from 5 to 10, I had to multiply by 2. So I have to do the same thing to this top number. 2 times 2 gives me 4. That's how I get this fraction. Now, same thing here. How do I get from 2 to 10? What did I multiply by? 5. So I'm going to put a little times 5 to remind myself, okay, I multiplied by 5. 2 times 5 gives me 10. So you have to do the same thing to that 1. You have to take that 1, multiply it by 5, and what do you get? 5. So step 2, I change my fractions. If you want to put a side note, you have to multiply, circle, or however you remember, okay, how to change your fraction. Any questions? This is a long and involved process if you're not used to it. Now, once you have them changed, step 3, add numerators. Bless you, by the way. Denominator stays the same. Denominator stays. So I have 5 plus 4 on the top, and I'm going to keep my denominator the same. What's 5 plus 4?
9.
9. And then my denominator stays the same. So my answer, since it cannot be reduced, is 9/10. Okay? Any questions? Fractions. I were you, I would highly recommend grabbing a note card and writing this information down on a note card. That way you always remember, okay, add, subtract, multiply, divide fractions. If you want one of mine, you can have one of mine. Okay? Now, powers. Powers. Write this down. Power is repeated multiplication of a number. Repeated multiplication of a number. And it looks like this. When it's written. Where B and E are variables. They stand for a number. B and E, in this case, are variables. We just talked about variables. They stand for a number. B here is the base. It's called the base. It tells what number to multiply. What number are you going to multiply? E is called the exponent. How many times am I going to multiply that number? How many times the multiplication repeats? Okay, or the B repeats. That's what the exponent stands for. B is my base, E is my exponent. We'll do an example here in a minute once you have these written down. Let me grab that door for me, please. Thank you. Are you finished?
Yeah.
You need to pass this study.
What?
You need to pass the study hall. All right, let's do an example. If I have 5 is my base, 4 is my exponent, that's called 5 to the 4th power. Okay? And what this means is 5 is the number I multiply, and I'm going to multiply it by itself 4 times. So I take 5, 1, 2, 3, 4. 5 times 5 times 5 times 5. It does not mean 5 times 4. I guarantee that I'm going to give a test or a quiz over this exponent using powers and exponents and bases. And somebody on the test, I'm going to put 5 to the 4th equals, and you're going to put 20. I'm going to say, no! 5 times 4, or 5 to the 4th power is not 20. Somebody's going to do it. And I'm going to cry. Okay? It is 5 times 5 times 5 times 5. Well, how do I do that? 5 times 5 is what? 25. Okay? 5 times 5, 25. I would do it this way. Now I have 25 times 25. Does anybody know what that is? If you have 25 quarters, how much money do you have?
$50.
$6, and if you have 24 quarters, you have $6. So if you have 25 quarters, so yeah, it's $625. We didn't have to use calculator. What's that? You need to. Did you not? Sorry. Go ahead. How many times multiplication repeats? It's the little e in the variable e. What's that? No, you do not. I'm just doing a word problem example. You do not have to write this down. Okay, this is actually a homework problem. I'm doing an example for you. Okay? What I would do is I'd write the problem down and say this is number 23 in your homework. There are 52 cards in a standard deck of playing cards. You are combining decks of cards so that you can play a game with a large number of people. the expression 52D, or 52 times D, represents the number of cards in D decks. If you combine 4 decks of cards, how many cards will you have altogether? Well, what information in the word problem can I use?
You can use, 52.
52 cards in a deck? Is that what you're talking about?
Yeah.
Okay. What else can I use?
4 decks.
Yeah, I need 4 decks. What else can I use?
It uses D.
Yeah, 52 times D, or the D decks, 52 times D. So I have my expression 52D, but do I know what D stands for? And all the other expressions we did, we had D equals. Can you say, give me a D equals?
4.
Yeah, D equals 4 in this case. Okay, if D is the number of decks, now I just have to solve my expression. I take my 4, plug it in for D, so I have 52. 52 times 4. We know how to do that. We just had a test over it. 108. 108 cards. What did I do? Oh, yeah, 200. 5 and 4 is not 10. It is definitely 20. Thank you. Now, make sure when you do word problems, 208 what? I forgot to put this down. Cards. There's the final answer. Any questions? Powers and expressions. Alright, I'll give you your worksheet. You have a little bit of time to work today.
Yeah, we're going to this iPhone.